about heaps, their indexing, and how to use a heap structure in a priority queue. I will provide you with two modules that will be a huge help when you're tasked with a heap question in a coding interview. So let's start. All right, a heap is essentially a binary tree with one type of order. Heap sort algorithm is sort of limited in use because a quick sort algorithm is usually more efficient as a better practice. Even though it's limited, the heap data structure is really used a lot. Other than heap sort, priority queues are probably the most prevalent in the real world. You can think of a priority queue as a modified queue. Instead of retrieving the next element by the order in which it was inserted, it retrieves the highest priority element. Priority queues are commonly used for dealing with scheduling problems and used in the implementation of algorithms. Priority queues can be completed using binary heap because it's supported with operations like insert, delete, extract max, decrease key, all in like log n time. You will often see priority queues in graph algorithms like Prim or Dijkstra's algorithm, and items are inserted into a priority queue in any sort of arbitrary order. However, items are withdrawn from a priority queue in order of their priority, starting with the highest priority item first or lowest priority item first, depending on if you have a min heap or a max heap. There are two properties. One is a min heap and one is a max heap. This order can start with the parent node being the max and the children node being lesser in value, or this can be a min heap where the parent node is the smallest and each additional child node is in higher value. Usually there are no more than two children off a parent node. In this binary heap, if the heap is a complete binary tree with n nodes, then it has the smallest possible height, which is log base 2n. In the diagram here, look at this tree on the left. You can observe a particular sequence. 2 is the root node, and it is the minimum valuable available. Then each node has greater value than any of its children. So here we have a min heap. In terms of priority queues, imagine there are n jobs needed to be completed, and then each job comes with its own priority. The job priority is identified with a value or a weight associated with it. So at each instance, we aim to complete a job that has the highest priority or weighted value. And at the same time, we are also interested in inserting a new job in the queue with its own priority. So when asked to create a priority queue in an interview question, we have to check which job has maybe the maximum priority and then insert a new job, considering there is one. This is where a heap is used, considering n jobs, a number of jobs, as n nodes, or the number of nodes in the tree. One of the most common ways to store these nodes or jobs is by using an array. An array can be used to simulate a tree, and the indexing, I think, is probably the most confusing part. Let's take a look at this diagram here. We can see we are storing the following 6 elements. Each will be a node or job in the tree. If we are storing one element at index I in an array, then its parents will be stored at index I divided by 2. Don't forget, we could always use trunc or truncate when dividing by numbers that result in a decimal. This will make it a whole number. We do need whole numbers to access our elements by indexing. Of course, though, if it is a root or parent node, then we will not have a parent node, above it. Now, its left child can be accessed by using an index of 2 times I plus 1. The right child can be accessed by using 2 times I plus 2. I think if you're confused with indexing when the elements are stored in an array, you should pause the video and check out this visualization. Find a parent node from one of the children by using the calculations, and then traverse through the tree by finding maybe the alternate size child Our root node will always be the first or the 0th element. Now, some like to use 0 and others like to use 1. Just make sure you adjust the calculations. And it's totally up to you. Just note the difference, that there is a difference if you start that array at the 0th element. There's no reason why a heap implemented in an array has to leave the item at index 0 unused. To keep it simple, I like to use 0 indexing, just because that's the way it is, and that's what you sort of have to deal with. Now that we have a basis to work from, let's assume we are given a list of jobs and the weight associated, and asked to convert it into a heap structure in a priority queue. So the question reads, how would you implement the priority queue with the information provided below that allows you to access the data structure? So here we're given a list of names and the priority associated with that name. So let's say the name is a job. Well, we have to reach out to John, James, Sally, and Marge. Well, James has the highest priority, number 1, and then it trickles down to John at the last. You should ask your interviewer any relevant questions, and don't be afraid to ask questions to make sure that you're totally informed and can provide exactly what they're looking for. So instead of writing some functions or a class that could handle this for you, don't forget that Python has a multitude of modules out there. And you guessed it, there is a module for working with priority queues. So let's talk about the heap queue module first. This is a binary heap implementation, usually backed by a plain array or list in Python. And it supports insertion and extraction of the smallest element in log n time. So this module is a pretty good choice for using priority queues in Python. Because heap queue technically only provides a min heap implementation, if you remember, that would make your root node the smallest, and as we traverse down, the values get larger and larger. You're going to need a few extra steps to ensure sort stability and other features typically assumed in a priority queue. So we're going to import heap queue here. Now, no need to pip or conda install, as this is native to Python. And then we're going to start with an empty array. What we will do here is just go down the list that we were given and insert a new job with its weight and let the module handle the rest. So considering most interview questions, it is extremely helpful to know what's out there so you don't have to worry about memorizing some code. If you know how to utilize a module and know what's going on under the hood, you'll be just fine. Next, we're going to use an attribute heap push. So with this here, we'll go heap queue dot heap push. Sometimes you could choose to store entries as a 3-element list, including priority, an entry count, and the task. But here we will work with just 2, keeping simple on your interview questions. So the first parameter is going to be where we're going to put this array. Next, we have a second parameter, and it's in a tuple form. Now, in this tuple form, we're going to have the priority. So let's start with the first one here, 4, which is for John, and that second parameter in the tuple will be the actual jobs. There are a bunch of other attributes you should be aware of, and particularly heapify, which transforms a given array into a heap in linear time. Heap push and heap pop, which we can assume we know what they're going to do. You might get an interview question where you are given an array and are tasked with converting it into a heap structure. So keep that heapify attribute in mind within this package. So let's insert the rest of these jobs using heap push, using the array in which the element will be located, this first parameter, the array in which it'll be located, and then in the tuple form, we will insert the priority, and then we will insert the name of the job. Now, if we wanted to access this information, we can also see how this is sorted in the array by using a Python while with the array. And let's define this. Do while jobs, meaning while there are still elements within our array. We're going to assign a variable next item to heap queue dot heap pull. Heap pop. We're going to be popping one off and then printing it out. This way we can check out the order. Next item, give it a whirl. And now we can see that it is in a correct order. It is an incredibly easy library to use and will definitely come in handy after you read the documentation and get an understanding of exactly what it can do. The next package we will obtain is from the Q package. The Q module has a bunch of different things usable when working with queues. It does use heap Q internally and shares the same efficiencies and time complexity. The main difference deals with threading and safely exchanging information between multiple threads. This module uses 3 types of queues, which differ only if the order in which the entries are received. These 3 are the first in, first out, the last in, first out, and the priority queue. This is a very handy package that has great impact in the real world, but in an interview question, you most likely do not need so much overhead. I'm a firm believer in picking up one package that you like and stick with it. There's so many different libraries, and choosing one and knowing one library instead of knowing the basics on multiple libraries. So I'll leave it up to you to choose the best package. Both of the modules used here have a link in the description below if you would like to take a look. Because this module is very similar, let's just take a look at the code. Let's import Q from import priority queue. So in this module, instead of creating an empty array, we will assign a variable to priority queue. So let's keep it the same just so we can see how this module works. So we're going to make jobs equal to priority queue, and that will act as our array. All right, now we're going to use the put attribute to insert these jobs into our array. All right, so we're going to put jobs, which is our array. We're going to do a dot put, 2 parentheses, because it's going to come in tuple form. So let's go with John first. Next, we'll do jobs dot put, insert James. All right, again, to check the order in which the items were inserted, we can use a while loop again this time, just sort of saying while this array still has some elements. Let's see. Let's take a look. So we'll say while not jobs.empty. Just another way to say while this array is not empty. We'll assign next item to jobs.get. And this is the same. Now this will do the same thing that pop does. And now let's print that next item, run the file, and we see that our array is in a nice order, nicely sorted. So I hope you have a better understanding of heaps and how they work. Take some time and learn the indexing, just in case you had some trouble with it. I think this is where most of the confusion lies. Well, at least for me and most of the posts that I did read online. So remember, heaps are just like a binary tree that has a particular order. Priority queues utilize the heap structure and takes into account these weighted values. So thanks for watching.